Hey, welcome to this Python object-oriented programming course. This series of video will guide you through the fundamentals and advanced functionalities of Python classes and inheritance. In this video, we'll start with the basics and gradually explore more complex concepts through hands-on coding in Python. Before we dive in, make sure you have Python installed on your system. For our development environment, we'll be using Anaconda as our Python distribution, and our integrated development environment or IDE will be Jupyter Notebook. So let's begin by installing Anaconda. To install Anaconda, just open your browser and search for Anaconda window installer, and then click on this link, Anaconda download. Then from here, click download and then just save the installer to your machine. And once you have it downloaded, just double click on the exe file and then click next. I agree. And then you can select if there are many users in your laptop, but so I'll just select all users since I am the admin of this laptop. Then just hit yes here and then select the location where you want to install. And then we'll just select the default. Okay, so once the installation is completed, just click next. And by the way, it will take some time to complete the installation. So hit next, and then I'll just uncheck this for now and hit finish. And after that, you can search Anaconda from your taskbar search, or you just type in Anaconda prompt and then double click on the app. And once you open your Anaconda prompt, you should see your user directory and then you will see an indication of base here. So this is different from your command prompt. So let's try if this is working. I will first create a directory and I will name it Python. And then I will go to that directory using the cd command. And then from here, I will open Jupyter Notebook. Okay. So if the installation is successful, you should see this page open in your browser. This is the Jupyter Notebook. From here, we can start creating notebook and start writing our Python code. Okay, so what is OOP? And to explain what OOP is, it is important that we understand first the fundamental concepts that build object-oriented programming. The first concept is class or classes. So what is classes? And I like to define it in a different approach. I think you are familiar with the built-in data types in Python, the basic data types and the complex data type. So if I want to store a value like a name, I can use a string data type, which is a basic data type. Or if I want to store a list of book title, I can use a list data type, which is a complex data type. But what if I want to store a complete detail of something? For example, a complete details of a student and the different functions that a student can do. What data type should I use? Well, we cannot use basic data type for that. Yes, we can do a combination of basic and complex data type, but it will make the code complex, hard to maintain, and possible that we encounter some limitations. What we can do is create our own data type, also known as custom data type in Python. And to create a custom data type, you need to use class. So using class, we can create a student data type. Isn't that amazing? So student is an entity and class is the blueprint for an entity. It defines what the entity looks like. And remember this, the class is not the entity, class is the blueprint for an entity, or in short, we use class to represent a real-world entity virtually. The class also defines the attributes and methods that its entity will have. So attributes are the characteristics of an entity and methods are the actions that entity can perform. And one good analogy is a house entity. And to represent a house entity in programming, you need to use class and define the attributes and methods of a house. So the attributes of a house are the number of rooms, size of rooms, color of rooms, and the number of floors. And the methods are paint room, fix appliances, set up electricity, and plumbing. And that representation of a house entity using attributes and method is called the blueprint. And now for the class to be useful, you have to create object from that class. And that is the second concept, objects. So using the class of the house, I can create, for example, three house objects and I will name them house A, house B, and house C. So imagine that these houses represents variable names and they have the same data type, which is house. And these houses are also called instances of the house data type. And that is the third concept, instances. The fourth concept is called inheritance. Inheritance is used to model entities using is a relationship. For example, we have a dog and German Shepherd entity. Using inheritance, we can create relationship to these two entities because German Shepherd is a dog. One good analogy is an employee. Each employee has the same attribute like an ID, name, and salary. However, there are different type of employee. For example, there are full-time employee and contract employee. And these types of employee can have different attributes like for full-time employee, the company offer them stock options, while for contract employee, they can have like overtime pay. If we are going to model this scenario using a single class, it could get messy. What we can do is create an employee class that contains the similar attributes across all the employees. And next, we can create another class for full-time employees that inherits from the employee class, so it can reuse the common attributes and create additional attribute that represents the stack options. And then we can create another class for the contract employees that also inherits from the employee class and create additional attributes that represents the overtime pay. In this way, we created three classes. The employee class is called the base or the parent class. Then the full-time and contract employee class are called the derive or subclass. Inheritance is extremely powerful and a great way to write reusable and maintainable code. So now, if we put all of this fundamental concept of classes, object, instances, and inheritance, that is what object-oriented programming is. Because in OOP, we treat everything like an object. If you are watching this video from a laptop device, in the world of programming, we can create a program that represents a laptop object. And to model that laptop object like a real world object, we can add attributes and methods to it. So attributes like the brand, the color, the processor, and the operating system. The methods are like restart, shutdown, play video, open application, and write code. And that is the basics of OOP that I can share to you. And it is extremely helpful that you understand this concept before we start writing code using OOP. Now that we know the basics, let's start showing this concept in actual coding. Okay, so let's start by opening Anaconda prompt and let's create a new directory using the mkdir command. I will name this OOP and then use the cd or change directory to navigate on that new directory. And then from here, let's open Jupyter Notebook. Okay, so from this page, let's create a new notebook. Make sure to select Python 3 and let's rename this notebook. I will name it one underscore class. And again, the first concept in OOP is class. And we use class to create a custom data type that can represent a real world object. So to create a class in Python, you need to use the keyword class followed by the entity. So in this example, we'll create a student class. So I'll type student and then a colon. And in the body of this class, we don't want to execute anything yet, so I'll just put pass. So now this is a simple but a valid class. So let's execute it by pressing Shift Enter. So once you have a custom data type, you can start creating an object of that data type. So let's create an object of student type and assign it to a variable name object1. So to do that, we'll just assign it equals to the class name, which is student, and we need to use the open and close parentheses. Now let's hit Shift Enter and that execute that line of code. So this process is called instantiation. So now object one is an instance of a student class. And now let's see what will happen if we print the object one variable. So hit Shift Enter and Python will display something like this. So this representation indicates that object one is an instance of the student class and it also provides its memory address in the computer memory where Python has placed the object. So this address is probably different on your output. So let's create another object of type student and this time I will assign it to variable name object2. And again, let's use the class name and then open and close parentheses. Let's execute this and let's also try to print the object2 variable. And again, we can see that object2 is an instance of the student class and also it provide a different memory address. So here you can notice that every time we create an object of type student, each object has its own independent existence. So if we change something in object 1, it will not affect object 2. And Python also provides a function that you can use to check if an object is an instance of a particular class. So for example, if we want to check if object 1 is an instance of a student class, we can use the function isInstance and then the object that we want to check. So for example, object 1 and then the class. So this function will return true if it is and false otherwise. So if we execute this, it returns true because yes, object 1 is an instance of a student class. Let's also check if object 2 is an instance of the student class. And if we execute this, yes, it is. Now let's try to create an object tree, but I will just initialize it using a blank dictionary. So this is a dictionary type of variable. Now let's use the isInstance function again to check if object tree is an instance of the student class. And if we execute it, it returns false because object tree is not an object. First, it is a dictionary and also it is not an instance of a student class. Remember that class defines the attributes and methods that its object will have. Right now, our class is too simple and it doesn't have any attributes and methods. So let's start to associate attributes to our student class. And one way to do that is using the dot notation. Remember that object 1 is an instance of the student class. So here we associate a name and email attribute to object 1. So if we execute it, our object 1 now has two attributes, which is name and email. And name and emails are like variable within the object itself. So if we want to know the name of object 1, we just need to type or print object1.name, execute, Now we have John. And if we want to know the email, we just need to print the object1 dot email. However, in this approach, before you can access the attribute value of an object, you need to assign value to it first. So if we try to access, for example, the age attribute value of object1, we will get an error because object1 does not have an attribute name age. And here we can also associate a name and email attribute to object2. So now if I try to access object2.name, it will return Mirna. Note that the attribute associated to an object using that notation only apply to specific objects of that data type and not all of the object. So for example, if we create a new object of type student and assign it to variable name object3, and if we try to print the name attribute of object3, we will get an error because object3 doesn't have a name attribute unlike the object1 and object2, even though they are all objects of type student. In order to resolve this problem, what we can do is we can redefine our student class. So in this updated code, we define the student class with three attributes: the name, the score, and active. So now every time we create an object from this class, each of those objects will automatically have the attributes associated to them. So now if we execute this, and so if we create new object of type student and assign it to variable name s1, and if we try to access the three attributes of s1 and execute this code, it will show the default value in the student class. And we can also change the attribute value using the dot notation. So in this code, we change the name of S1 object to Joseph and also the S1 score to 75. So if we execute this and if we try to access again the three attributes of the S1 object, we are getting the updated value. So now let's create another object of type student and I will assign it to variable name s2. And again, changing the attribute value of an object will not affect the other object. So if I change the name attribute of s2 to, for example, 1, this will not affect s1. And we can check that if we try to print s1.name and s2.name. So here we can see that the S1 name is still Joseph and our S2 name is now Juan because that's the new name we assigned to that attribute value of S2. Okay, in order to make a powerful custom data type, we should initialize value for class when you create object from that class. And now class attributes can be a variable or functions, and a function that is defined inside a class is called a method. And in Python, there are special methods associated to class. And one example is the init method. So special methods are indicated by the double underscore before and after the method name. And the init method initializes the Python class object when created. So in this example, our init method contains a one argument named self. And this self refers to the class object itself. And to associate a method to a class, it should be passed as the first argument. So now if we execute this code and if we create an object of type student and assign it to a variable s1, we can see here that Python automatically invokes the init method and passes in the object itself as an input argument to the function. And it will be the same every time we create new object of type student. So for example, we create another student object and assign it to s2 variable. Again, if we execute the line of code, uh, Python will automatically invoke the init method, which calls the print function showing initialize code. Let's do another one. Let's assign that to S3 variable. And again, we have the printed text as an output. So now if we try to redefine our student class and remove the self argument in the init method, and execute this code, we will not get any error. But if we try to create an object, for example, maybe S4 of type student, and if we execute that code, we will get an error because if we inspect the error, it says that the student init method takes zero positional argument but one was given. And why is that? It is because Python passes in the object itself as an input argument when invoking a method. And here in our new redefined student class, we are not allowing any argument to be passed in this init method. That's why we are getting this error. And just an additional, we can replace this self keyword with other keyword, like for example, a boo, a pencil, a mouse, or anything else. But based on the standard practice in Python code, self should be the name of the first argument because that will give us consistency and it will be easier for the other programmer to understand your code. Okay, so now let's use the init method to initialize the object of class. And in this updated student class, we add additional argument name to the init method. And inside the init method, we are assigning the value of name to the property of the object instance, which is referred to by the keyword self. We also have a mail property, which is equals to the name and concatenated to the default email domain. So if we execute this code and if we try to create a new object of type student like this, if we execute that code, we will now get an error because now the init method is expecting additional value. And because of that, to create a new object of type student, we need to specify additional value. And that will be passed to the name argument of the init method. So let's say, for example, we'll use Joe. Now, if we execute this code, it works. And notice that you don't need to pass a value to the self argument. It is because Python takes care of that for you, but you need to specify a value for the additional argument, which in this case we have the name argument. And now if we also try to specify more values than what is required, we will also get an error. Okay, and now if we access the name attribute of the object S1, it will return Joe because again, when we create the S1 object, we specify a value which is passed in the init method name argument and then assigned to the name property of the instance of that object. And that is the same if we access the mail property of the S1 object, it returns joe at abc.com. And again, we can update the value of the object attribute by assigning a new value. So for example, we can change the name of S1 object to Andrew, for example. And now if we check S1 name, we get the updated name, which is Andrew. And remember that the changes we made in one object will not affect the other object from that same class. So let's try to create a new object of type student and assign that to variable s2. And here let's specify a name, for example, Carl. Now if we try to access the name and mail of s2 object, we get Carl and I'm sorry, it should be mail. Let's run it again. Now we have the name as well as the email for Carl. So if we try to change the name of Carl into Joseph and execute that line, now let's check what is the value of S1 and S2 that name. And if we execute it, we can see that S1 name is still Andrew, and it is not affected. The only affected object is S2 because there is where we updated the attribute value of name. So now we get the updated name value, which is Joseph. So just a quick recap, in our previous discussion, we started with a simple class and learned how to redefine it by associating attributes. We then defined special methods such as the init method with default self-argument. And additionally, we explored how to add extra argument to initialize object instance properties. So now let's delve into defining additional methods in classes to enhance their functionality. In this new version of the student class, the init method takes the default self argument together or along with two additional parameters. So now every time we create a student instance, we must specify a first and last name. And these values will be assigned to the first and last attributes of the object respectively. We also construct an email by combining the first and last names with a default domain and assign it to the mail attribute. We've also introduced a new method called full name with the default argument self, and this method will return the first and last name in a string format. So now let's execute it. And now if we create a new object of type student and assign it to variable s1 and execute this line of code. So if we try to access s1 that full name, it will return Richard Feynman. And similarly, creating another object and assigning it to s2 variable, execute this code. And now if we try to access s2 that full name method, it will return Cal Newport. And you may come across a syntax like this, and this syntax is equivalent to s2 that full name. So here we refer to the class name first, and then we indicate the method and then specify the object instance where we want to invoke the method full name. So if we try to execute this code, it will return Cal Newport because Cal Newport is the full name for the s2 object. We can also check the full name using this syntax for the S1 object, and this will return Richard Feynman. And now let's create a third student and then assign it to the S3 variable. So this third student is Carl Jung. Now if we try to execute it, we can still access the object attribute like the first attribute using the dot notation. So we'll just indicate the object and then the attribute that we want to access. So in this example, it returned Carl. And in Python, we can use the del command to delete an attribute of an object without affecting other object of the same class. So for example, we can delete the first attribute of the object S3. So if we execute that code and if we try to access the S3, that first attribute, we will get an attribute error because now the S3 object no longer have the attribute first. However, if we try to access the last attribute of the object S3, it still work as expected because we still have the last attribute present in the S3 object. So what if we invoke the full name method on S3? What do you think will happen? So let's try to invoke full name method. If you think it will have an error, then you are correct. Now we get an attribute error because student object has no attribute first. Again, this full name method requires both the first and last attribute. And again, remember that changes made to one object will not affect other objects. So if we try to invoke the full name method in or on the S2 object, it will still return Cal Newport. And additionally, Python allows you to use the del function not just to delete an object attribute, but you can also use it to delete the object itself. So for example, we can delete S3. So now if we try to access S3, that last attribute, we are now getting a different type of error. This time this is a name error because S3 is no longer defined. Another example, in this updated version of the student class, the init and full name method remains the same, and a class in Python can have any number of attributes, whether variables or methods. So here we've added a method called uppercase with the default argument self. And this method updates the values of the first and last attributes by converting them into uppercase and then assign them back to the respective attributes. So now let's execute this code and let's create two students and assign them to S1 and S2 variable. So if we execute it and if we try to access the full name method on S1, it returns Carl Jung, and for S2, it returns Richard Feynman. Now let's try to invoke the uppercase method on S1, and now let's check again the full name of the S1 object. And as expected, Carl and Jung are now in the uppercase format. And again, remember that changes made to one object do not affect other objects of the same class. So if we try to access the full name of the S2 object, it will still return Richard Feynman in its original format. Okay, so now let's discuss the difference between class variable and instance variable. And these are the two types of variable that you can see in a class. So here we have a new class credit. And here you will notice that we have different types of attributes. And this one, the one outside of the class functions or method and not referred to by the keyword self, these are known as class variable. And these variables are associated with the class itself and not with a particular instance of the class. And on the other hand, these attributes inside a function or a method that are referred to by the keyword self, these are called instance variables. And these variables are associated with a specific instance of a class, not the class itself. So remember, class variable are associated with a class, whereas instance variable are associated with the instance of the class. So here in our credit class, we also have an interest value or variable that is not referred to by the keyword self. So let's see later if this will cause an error when we access the raise amount method. So keep an eye on that variable. Now I will execute this code and now let's create an object of type credit. So for example, a laptop with an amount of 700 and then let's store it in a variable named laptop. And then we'll attempt to access the interest value, which is this attribute here in our class, using the laptop object. So we should be able to access the interest attribute value using the object created from the credit class, which is the laptop. So now if I execute this code, it returns 1.05, which is the interest value in our credit class. And since the interest variable or attribute is a class variable, another way that we can access it is by using the class name. So that is the credit, and then we'll use that notation to access the interest attribute. And if we run this code, we will get the same result. So here's a question for you. Do you think we can access the name and amount attributes using the class name? Well, let's find that out. If we try to access credit name and credit amount, we will get an attribute error because the credit class has no attribute name. And remember, the name and amount are instance variable. They are associated with an instance of the class, not the class itself. So in this example, the laptop is the or an instance of the credit class. So if we want to access the name and the amount attributes, we need to refer to them using the object where they are associated, like laptop name and laptop.amount. So if we execute this code, it returns laptop and 700. So now let's see what will happen if we invoke the raisEamount method on the laptop object. And here we get an error because the interest variable is not defined and Python doesn't recognize this interest variable. So to solve this problem, we need to fix our code by referring to the interest variable using the class name. So in this way, Python can identify that it is a class variable. Now let me execute this code. And next, let's create another object of type credit. And this time we'll call it internet with an amount of 100. And then we'll store it to a variable named internet. And let's also try to access the name and amount attribute using the internet object. So it returns a value because name and amount against our instance variable and they are associated to the instance of the class, which in this case is the internet object. So now let's invoke the raise amount method on the internet object. And if we try to print the internet amount and execute this code, we can see that it increases by an additional 5% after invoking the raise amount method. It is crucial to understand the difference between class variables and instance variable. And to further illustrate this difference, consider our updated credit class here. And here I've introduced a class variable customer of type list. And then I've created three objects, laptop, car, and internet, all of type credit, and each with specific values assigned. So let's execute this. So additional for a class variable, if you access it from any object created from the credit class, you will obtain the same value if we execute this code. It is because all these objects point to the same memory address in our computer's memory. And so similarly, if you update the value of a class variable from any of the object created from the credit class, like the laptop, and then if we access again the customers variable from these objects, all of this object when we execute this code will reflect the updated value. So here's another example. We will try to update the customers variable from the car object. And again, if we access the customers variable again from all the objects that are created from the credit class, including the credit class itself, and if we execute this code, again, we obtain the same value from each of these objects. And then again, class variables are associated to the class itself. So if we check the dictionary of the class credit, we can see in here that the customer's value are present as well as the current value of the customer's list. But checking the dictionary of laptop, for example, what we can see or what we can only see here are the instance variable that are associated to the laptop. And it is the same if we check the dictionary of the car object. We only see the attributes or the instance variable associated to the car object. So now in the case of instance variable, these variables refer to different locations in the computer's memory when the objects they are associated with are created. So in this class that we have, the name and the amount are the instance variable because they are inside the special method init and they are also referred to by the keyword self. So if we check the value of the name attribute for each object of type credit, and if we execute this code, we can see that we are getting or obtaining different values. And then if we check the name attribute value for each object again, we can observe that the updated value only reflects on the laptop object. And this is because the attribute we updated is only associated to that object and it does not affect other objects of the same class. Well, if you have experience in Java, variables in the class could be a public, a private, or a protected. However, in Python, both class and instance variables are public by default. So here we have a new class book, and in the init method, we have the self as the first argument, then we have additional two input arguments, the title and then the genre. Then we assign these input arguments to the title and genre property of the book instance. Then we also have here a method show details that simply print the title and the genre of the book instance. So let me execute this. And here we create a new object of type book. The title is The Power of Positive Thinking, and it is a self-help book. And then we also invoke the show details method. So now if we execute this code, it print book title is The Power of Positive Thinking and genre is self-help. Then if we want to change the title of the B1 object, we can easily do it using the dot notation and assign a new value. For example, is deep work. So now if we invoke the show details method again, we can see that the title of B1 is now deep work. Another fundamental concept in OOP is the data encapsulation. So the idea of data encapsulation is that data which lives inside a class should not be accessible to the code outside. So what we did here is not aligned to the idea of data encapsulation because this line of code here is outside of the class, but we are able to easily access and change the value of the attribute title. And now this is another important concept. If we check the dictionary of the B1 object, we can see the instance variables that are associated to this object in a key value pair format. And we were able to access and change the value of this attribute by using the dot notation and refer to the key. For example, is the title. So here I made an update to our book class. In Python, there is what they called a hack to make the variables private. And that is by using the double underscore as prefix to the variable name. So in this updated class, we added a double underscore prefix to all the instance variable. Now, let's see why this is a hack. Let me execute this first. And then let's create a new object of type book. So the title is Moby Dick and it is a fiction book. And let's also invoke the show details so we can see the details of the B1 object. So book title is Moby Dick and genre is fiction. So now if we access again the dictionary of the B1 object, observe that the key format is now different compared to the previous one. Now it starts with an underscore followed by the class name, then the double underscore, and then the attribute name. And now again, let's update the B1 title using the attribute name, this time with the double underscore as a prefix, and then let's set the value to Ikigai, and let's invoke show details. And if we execute it, we can see that the title is still Moby Dick. It did not change. And why is that? Well, if we again access the dictionary of the B1 object, you will observe that, or you can observe that we have a new item here, this part, which is the double underscore title, and it has the value Ikigai. So what happened when we execute this code here is that it did not update the title attribute value, but instead it creates another attribute on the object. That is why we have now three attributes here when we access the dictionary of the B1 object. So using the double underscore prefix to the instance variables make it a private variable. But as mentioned earlier, that is only a hack in Python. If you really want to access and update the value of a class attribute outside of the class and you know how to, then you can do it. I tell you that because if we instead use the key format and the B1 dictionary as you see in this part of our output, we can now access the title attribute of the B1 object and then update its value. So again, let's use this attribute format and then set the title to Ikigai and then let's invoke show details to see what will happen. Let's execute this. And now we can see that the book title was updated to Ikigai and the genre is still fiction. So the use of underscore just make things a little bit harder for us to change the attribute value outside of the class. But But that is a standard way of making variables private in Python, and that is what Python programmers follow. Okay, here we have an updated class book, and the init and the show details method are still the same, and we are making all the instance variables private by adding a double underscore as prefix. Then we have additional method change title with self as the first argument and a title. And inside this method, we can change the value of the title attribute based on the specified title when this method is invoked. So now let's create a new object of type book. Title is Think and Grow Rich, and the genre is a self-help. And then let's invoke again the show details method to print the title and genre. And if we execute it, it works as expected. It says book title is Think and Grow Rich, and the genre is self-help. And now let's invoke the change title method and specify a new title, start with Y. Then let's invoke the show details method again. And if we execute this code, we can see that the title was updated to start with Y. And remember, the idea of data encapsulation is that data which lives inside a class should not be accessible to the code outside. So what we did here is first, we make all the instance variables private, and also we added a method that act as a setter. So now instead of us directly accessing and modifying the attribute value outside of the class, we added a method that we can invoke to do that for us. And here again, we have an updated class book, and we added a new instance variable topics of list type. So in our show details method, we also print the topics of the book instance, and observe that we have additional methods that starts with set and get, and these are what called getters and setters. Even though there is a way to access and change the instance variables value outside of the class, it is not a good practice. The standard practice is to use setters and getters. And developers should follow this standard practice to allow other developers to access and change your instance variable in a standard way. And we should use setters and getters rather than accessing instance variable directly. So now let's execute this updated class. And here we created another object of type book and set the title to eat.frog and the genre to self-help. Then invoking the show details method to print the title and genre of the book. So once we execute it, we can see that the book title is Eat That Frog, the genre is self-help, and then we have a topic printed as well, but now we don't have any item in that list yet. So now let's add a topic to B1 instance and invoke the show details method. And now we can see that we have one item in our topics list. And now if we want to change the genre of this book instance, we can invoke the set genre method and specify the new genre. So for example, we want to update it to nonfiction. And if we execute this, now the genre of this book instance is nonfiction. Okay, another update to the book class. So what I did is just add a documentation which is indicated by the triple quotes. Then I added a method or a setter that can update both the title and genre in just one invocation. So now let's execute this updated class. And if you are curious about the documentation part, you can access that by referring to the class, which is book, and then use the doc method with the double underscore as prefix and suffix. So if we execute this code, it will return the string that is inside the triple quotes in our class. Now let's create a new object again of type book. The title is Deep Work and it is a nonfiction book. And again, let's invoke show details and it works. And now that we have a setter that can update both the title and genre at once, we can use it to update our book title to The Art of Thinking Clearly and the genre to self-help. So now let's execute this code and we can see that the title of the book now is The Art of Thinking and the genre is updated to self-help. Okay, so I have an exercise for you. I want you to create and define a class for a laptop. So this laptop class should have these attributes, a name, a model, the apps or a list of apps that are installed, and then an indication if it's updated or not. So please think on how you are going to build this class. Later, I'm going to show my solution, but please, I want you to think of it first before you look at that solution. You can always go back to the topics that we've discussed for you to build this laptop class. So please pause the video now and create your laptop class. Okay, so again, this solution could probably be different from what you have built, but this is an example based on what we have discussed in this video and also using the best practices in the Python standard. So here I define a class laptop, and then we have here a one special method, the init method with self as the first input argument, and then we have two additional input arguments, the name and the model. And then inside this method, we are setting the name and model properties by the name and model that was specified when creating an instance of this laptop object. And then we also have an apps property, which is of type list, and we initialize it to a blank list. And then we also have an updated property, which by default is set to true. And then here we have setters. Uh, to the first method is to set name. If we want to modify the name, we can call the set name method. If we want to change the model, we can call the set model method. And if we want to add apps, we can call the install app and just specify the app that we want to install. We can also uninstall app by calling the uninstall app method and also specify the app that we want to uninstall. And then we also have the set update method to set the updated property to true. And lastly, we have the show details method just to print the details of the laptop, like the name, the model, so the apps installed and if it's updated or not. So now let me execute this class and let me create a new object of type laptop. I will name or I will store it to variable Acer. So now let's refer to the class and then specify the name. It will be Acer and then the model is Nitro 5. And now let's execute that line. And let's also install an app to this laptop object. So I will invoke the install app method and then specify the app that I want to install. So for example, is Word, execute that. And now if we check the details of our Acer object, we can see that this is an Acer laptop with a Nitro 5 model, and then we have one app which is Word, and it is updated because it shows here true. We can install another app by invoking again the install app, this time maybe PyCharm, and then let's also check the details after installing another app. Now we can see here that we now have two apps installed in our laptop object, and we can also modify the model by calling the or invoking the set model method and specify the new model. For example, is Predator. I hope I have a Predator laptop. Execute that, but let's invoke the show detail first so we can see if it is successful. And yes, the model is now updated to Predator. And lastly, we can also uninstall app because we have a method to uninstall app. So let's call or invoke that method. And let's uninstall the Word app because maybe I don't need it. So let's also show the details of our laptop. And now we can see that we only have now one app remaining, the PyCharm, because we just uninstalled the Word app. So I hope you have the the working laptop class. Maybe you have additional functions that I don't have here, but I hope all of the topic that I discuss help you and you can now start working with class. But what we have discussed so far are the basic of class. We've started with the concept and then we do it step by step for you um, to understand how to really build a class and what are the specific part of class. So we started with a simple class and then we we st- we then added some methods, the special method, the init method, and then the other methods like the show details, and then we created 5-bit variables by adding the double underscore prefix to the variables. And then we also use the setter and getters, which is the standard practice in Python, and to align with the idea of data encapsulation. So in the next video, we'll talk more about object-oriented programming. We'll talk about instances and polymorphism. So I'll see you on the next video.